This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. At the bottom of a stucco wall, the most important opening is often the one somebody's tempted to bury, caulk, or make disappear. That opening belongs to the weep screed. I want you to think of the screed as the wall's moisture exit. Water that gets behind the plaster needs a continuous route down the water-resistive barrier and out at the foundation line. If the exit is blocked, or if the layers send water behind the screed instead of over it, the assembly can hold moisture where the wood framing is most vulnerable. The central principle is simple. Keep the drainage path continuous and keep the exit open. The weep screed does not make the wall waterproof by itself. It works only when its position, its clearances, and the layers above it all cooperate. That is why a small metal accessory at the bottom of the wall becomes a major field supervision checkpoint. Portland cement plaster is porous. When the bottom edge is allowed to stay in contact with wet soil, mulch, or standing water, moisture can move upward through small pores by capillary action. The practical effect of the required gap is that it separates the porous cladding from persistent moisture and leaves the drainage edge exposed. I do not need to claim that every buried screed produces the same damage. Conditions vary, but I do want you to recognize the supported consequence chain. Reduced clearance can block drainage and support wicking. Persistent dampness can reach adjacent materials, and the repair can become far more invasive than preserving the clearance in the first place. The source report for this lesson cites the 2022 California Building Code and California Residential Code provisions for the dimensions and placement I'm about to give you. For a live project, I would still verify the adopted code edition, approved plans, manufacturer instructions, and local amendments. Looking at the reference table, start with the screed itself. The cited provisions require a corrosion-resistant weep screed with a minimum metal thickness of 0.019 inch, identified as number 26 galvanized sheet gauge. The vertical attachment flange must be at least 3½ inches high. That flange is not wasted metal. It provides the surface that the water-resistive barrier and exterior lath must overlap at the bottom of the wall. The screed belongs at or below the foundation plate line on an exterior stud wall receiving cement plaster. Then come the two clearance numbers I want you to hold on to. The screed must be at least 4 inches above earth and at least 2 inches above paved areas. Earth includes the conditions that commonly stay damp, such as soil, grass, and mulch. A paved area includes a concrete patio, driveway, or walkway. I remember the pair as earth gets the larger gap. 4 over earth, 2 over pavement. The memory aid works because soil and landscaping can hold moisture and can also rise over time as mulch, rock, or topsoil is added. Hardscape can still collect splash and water, but the cited minimum is smaller. The rule is not 4 inches from some convenient mark on the wall. It is 4 inches from the finished earth condition to the weep screed. The same idea applies to the 2-inch paved clearance. Final elevations matter. Imagine a contractor who checks the screed before landscaping, sees a clean 4-inch gap, and moves on. A landscaper later adds several inches of mulch against the wall. The stucco work did not physically move, but the final condition changed. The drainage edge is now buried. The useful supervision habit is to check the relationship at the stage when grade and hardscape are actually established, not only when the lath is first inspected. The same issue appears in remodeling. Suppose a patio starts with 6 inches from the slab to the screed. A 3-inch paver overlay is proposed. The remaining clearance would be 3 inches. That still exceeds the cited 2-inch minimum. If the starting clearance were only 4 inches, the same overlay would leave 1 inch, which would not meet that minimum. A simple elevation check before ordering material can prevent a difficult stucco correction later. I also want to separate the weep screed from a plaster stop. A weep screed is made to drain at the base of the wall. A plaster stop creates a clean termination, but it does not provide the same drainage function. At the foundation line, do not treat every piece of termination metal as interchangeable. Identify the accessory by what it must do. A correct screed can still fail as part of the assembly if the layers are installed in the wrong order. Water management depends on Shingle-Fashion. An upper water shedding layer overlaps the lower component, so gravity keeps water moving outward and down. The sequence table begins with the weep screed against the framing or sheathing at the base. Next, the water-resistive barrier comes down over the wall and laps over the screed's vertical attachment flange. Then the exterior lath covers and terminates on that flange. The code language matters because it describes a connected path, not three unrelated products. Picture water traveling down the face of the water-resistive barrier. With the barrier lapped over the flange, the water reaches the front of the screed and can leave the wall. Now reverse that one lap. If the barrier is tucked behind the screed flange, water can be directed behind the drainage accessory, toward the foundation plate area. The products may all be present, but the drainage logic has been defeated. That is the inspection mindset I want you to build. Do not stop at asking whether the screed, paper, and lath are on site. Ask whether they are integrated in the order that lets gravity work. Presence is not performance. The bottom opening also has to remain open after the wall is finished. Caulking along the drainage edge may look neat, and a homeowner may think the gap is an insect opening or an unfinished joint. But sealing the weep path traps water that reaches the base. I would explain the condition plainly. This is a design drainage exit, not a cosmetic crack. Pest control details, sealants, and finish work must not erase the drainage function. There is a useful connection here to roofing and flashing. The materials are different, but the governing idea is familiar. Water should not be asked to travel uphill or cross behind a lower flashing edge. Each upper layer sheds onto the layer below. At the base of stucco, the weep screed is the final lower component in that chain. Openings and penetrations require the same disciplined thinking, even though their exact details depend on approved plans, code provisions, and product instructions. A general building contractor is not expected to improvise a custom wall design. The field role is to coordinate the specified assembly, protect completed layers, verify that laps are not reversed, and stop the work before plaster conceals a visible defect. The water-resistive barrier requirements in the source report change with climate conditions when stucco is installed over wood-based sheathing. I want to keep this precise because a slogan like 2 layers everywhere would oversimplify the cited provisions. In the dry climate condition described by the California Building Code source, the barrier must provide performance equivalent to 2 layers of grade D paper, or use a single 60-minute layer separated from the plaster by a drainage space. The key idea is that the assembly preserves a functioning water-resistive layer and a route for incidental water to move downward. For moist climate zones identified with the letter A and marine climate zones identified with the letter C, the cited provision requires a drainage space at least 3/16 of an inch deep on the exterior side of the water-resistive barrier over wood sheathing. That is a physical drainage space, not merely a promise that the materials will somehow drain. I would not choose the climate approach from habit or from whatever product is left in the truck. I would confirm the climate classification, the adopted code, the approved wall assembly, and any product-specific requirements. The general B skill is coordination. It is recognizing when the wall needs a defined drainage space and making sure that the specified layers actually continue down to the screed. The barrier also needs protection during the sequence. A properly selected system can still be compromised by tears, careless fasteners, missing laps, or later trade damage. Before lath and plaster hide the paper, I would make the wall available for the required inspection and correct visible defects. Once cement plaster is in place, a reversed lap or torn barrier is no longer a small correction. The report explains a practical physical distinction between bonded and separated layers. Wet plaster can bond to the outer layer that receives it. A separated inner layer or dedicated drainage space can preserve a path for water. I am using that as a building science explanation, not as permission to substitute an unapproved assembly. The actual project still follows the adopted code, approved plans, and listed or specified materials. The lath is the plaster's mechanical support, and a few numbers control whether it can become properly embedded and remain continuous across the wall. These are good pre-plaster inspection checkpoints because they disappear quickly once the scratch coat begins. For metal lath applied over a solid substrate, the cited lathing standard requires at least 1/4 inch of furring away from the backing. Self-furring lath can create that separation through its formed shape. The purpose described in the source report is practical. Wet plaster needs room to move behind the mesh and encapsulate it, creating a mechanical key. Lath flattened tightly against plywood or oriented strand board loses that intended space. Expanded metal lath must overlap at least 1/2 inch at side laps and at least 1 inch at end laps. Those are minimum overlaps, not approximate visual targets. The sheets need continuity across joints instead of meeting edge to edge. Fasteners attaching the lath to wood framing must penetrate the framing at least 3/4 of an inch. Along the studs, the cited maximum vertical spacing is 7 inches. That means a fastener pattern can be wrong in 2 different ways. The fastener may be too short to achieve the required penetration, or the fasteners may be spaced too far apart even if each one is long enough. I would verify the substrate, lath type, orientation, laps, fastener type, penetration, and spacing before approving plaster placement. The source report focuses on the values for expanded metal lath and wood framing. Other substrates or proprietary systems can have different requirements, so I would not transfer these numbers blindly. Here is a concise hypothetical. Suppose a crew uses self-furring lath but crushes the dimples flat with overdriven fasteners. The product name still says self-furring, yet the working space behind the mesh may be reduced. The inspection question is not only what product was delivered, it is whether the installed condition preserves the required offset and fastening. I also watch sequencing around corners, openings, accessories, and transitions, because the lath has to work as part of one plaster base. Exact reinforcement details should follow the approved assembly and reference standard. The supervision principle is continuity. Gaps, reversed laps, weak attachment, and damaged paper are easier to correct before the wall is covered. Stucco scheduling is where a contractor can understand every physical layer and still create a problem by rushing the calendar. Portland cement plaster gains strength through hydration. It needs water for the chemical reaction. Saying that it simply needs to dry points the crew in the wrong direction, especially in hot, dry, or windy weather. The cited curing table requires the scratch coat to receive at least 48 hours of moist curing. The brown coat also receives 48 hours of moist curing. After the brown coat, the cited minimum interval before the finish coat is 7 days. I want you to hear the distinction in the verbs. Moist curing means retaining or supplying moisture, so hydration can continue. It does not mean flooding the wall, and it does not mean ignoring weather or project specifications. It means the base coat is intentionally kept damp under the applicable requirements, rather than left to lose water as fast as possible. The 7-day interval after the brown coat is also a scheduling constraint, not idle time that can be deleted because another trade is waiting. The source report connects that interval to initial curing and shrinkage of the base coats before the finish is applied. Rushing the finish over a young brown coat can increase the risk that later movement and shrinkage show through as cracking. A capable superintendent uses those waiting periods instead of fighting them. Interior work, inspections, cleanup, material staging, and other non-conflicting tasks can continue while the plaster cures. The calendar should show the cure and interval as planned activities. If they are invisible in the schedule, somebody will eventually treat them as delay. Imagine a project manager who promises the finish coat based only on the day the brown coat is placed. A weather shift then increases evaporation. The moist cure is not staffed, and the finish crew is still booked too early. The correction is not a motivational speech. It is a realistic sequence with responsibility assigned for curing, documentation, and release of the next coat. I would also record the placement dates and curing actions. The source report does not prescribe a special form for that record, so I am not inventing one. A simple project log can still help the contractor verify that the required interval was respected and explain the sequence during inspection or quality review. Several common defects become easier to recognize when I reduce the assembly to 3 questions. Can water get onto the drainage plane? Can it travel downward without a reverse lap or block space? Can it leave at the screed with the required clearance? If landscaping covers the screed, the exit is compromised. If a raised patio or paver overlay reduces the gap below 2 inches, the final elevation is the problem, even if the original stucco was correct. If sealant closes the bottom edge, the exit is blocked. If the water-resistive barrier runs behind the flange, the path directs water the wrong way. If lath is pressed flat against a solid substrate, plaster encapsulation can be reduced. If curing is rushed, the base coats may not develop as intended. Notice that these are coordination failures across trades and time. The stucco subcontractor may install a compliant screed, and the landscaper can bury it months later. The wall crew may install the barrier correctly, and another trade can tear it before lath. The plaster crew may place a sound brown coat, and the schedule can force the finish too soon. General building supervision means protecting the whole sequence, not grading one trade in isolation. A practical turnover check should include the visible base of the wall. I would walk the perimeter after final grading and hardscape, confirm the clearance, look for caulk or debris blocking the screed, and document questionable areas before closeout. I would also communicate the drainage purpose to the owner, so later landscaping or cosmetic work does not unintentionally erase it. The weep screed is sometimes called an exit, but it is not a magic emergency drain that compensates for every defect above. Bulk water still has to be limited by the cladding and managed by the specified barrier and flashing system. The screed is the terminal point of that drainage path. That is why both the upstream layers and the downstream opening matter. Safety remains part of stucco coordination. The source report identifies 2 points that are easy to confuse. First, the application of wet stucco and plastering material is exempt from the specific California dry silica dust control regulation cited in the report. That exemption is narrow. It does not mean every task involving cement base material is free of respiratory hazards. Cutting, grinding, mixing, cleanup, and other operations must be evaluated according to the task, the safety rules, and the employer's program. I would never turn one exemption into a blanket statement that no protection is needed. Second, plastering scaffolds must support their own weight plus 4 times the maximum intended working load. The report lists light duty at 25 pounds per square foot, medium duty at 50 pounds per square foot, and heavy duty at 75 pounds per square foot. Wet plaster, workers, tools, and staged material can create substantial loading, so the intended load has to be established rather than guessed. The general B boundary is coordination and verification. I am not designing a custom scaffold or a custom stucco assembly from these study numbers. I am making sure the competent people, approved plans, manufacturer instructions, inspections, and applicable safety requirements are in place before work proceeds. Here's the compact memory connection I would carry into field supervision. 4 over earth, 2 over pavement, paper over flange, lath on a flange. Keep the exit open, then protect the cure. 48 hours for the scratch, 48 hours for the brown, and 7 days before the finish. That sequence gives the numbers a physical home. The clearances protect the bottom edge. The lap directs water onto the screed. The lath supports the plaster. The curing time protects the cement reaction and the finish schedule. When a question or job site condition feels complicated, return to the path water must follow and the time cement needs. I made an audio practice quiz specifically for this episode's stucco assembly and weep screed material. It is audio-based, so the questions are read aloud and you answer by tapping. I designed it for people studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the weep screed, water-resistive barrier, lath, clearances, curing, or safety points I covered. I read those questions because they show me where the explanation needs to be sharper. Subscribe so you can stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I am here to help you keep moving.